So I think we completed till over here, and we were on understanding of the spring forces and all, and we get to know how to consider the spring forces. Today, our task is to continue this topic and do some questions on gravitational and spring potential. Now, moving on to this topic, what does this topic tells us about? See, we have two spring, like again same thing, just like last question. What happens if we cut the first spring, and what happens if we cut the second spring? So first of all, I'll draw the FBD. This is 5 kg. So its weight is 5g. This weight will be 10g. This one will be a spring force one. I'll draw the 10g side. This is spring force 1. This is spring force 2. This is sorry, spring force 1 only, because I'm looking on the first spring itself. Is that clear or not? This will be spring force 2, and this will be spring force 2. Now look over here. In equilibrium, okay, or in the steady state, the value of spring force 1 will be how much? Fs1 will be simply 5g, and Fs2, this one, will be how much? This is Fs1 plus 10g, which is 5g plus 10g, which is 15g, correct? Now case 1 is, what is our case 1? When the spring 2 is cutted, what will happen? Tell me first. Case 1, what will happen if the spring 2 is cutted? One minute, I can't hear you. Now you tell me, what will happen? Both the bodies will move with acceleration. How much acceleration? You have to tell me how much acceleration. So look over here. What happens when we cut the spring 2? Let's suppose if we see on the blocks, okay, if we see the blocks properly, then uh, uh, both blocks will fall with 10 meter per second square. So let's see it clearly. See, when 2 is cutted, okay. So I am cutting the spring 2. I switch off your mic. It is creating a little bit of problem. Hello, hello. So let's suppose if I cut the spring, this is spring. So I know that first case is on 5 kg block, there is no opposing or something kind of force. So it will fall down with acceleration g, definitely, because has happened. So look over here. Case A means For the 5 kg block, hello. Okay, okay. So for the 5 kg block, acceleration of 5 kg will be simply equal to g meter per second square. Is that clear or not? Now, if I take 10 kg, as we know that, please mute your mic. For 10 kg block, as we know that, the spring forces are lazy. Spring forces are lazy means what will happen? This Fs2 will not change instantly. Means this Fs2 will change after some time. The question arises, after how much time? So look over here, means see, Fs1 will become 0, means if spring 2 is cutted, you can say that Fs1 will become 0, but Fs2 will not become instantly 0. So this means that if I try to think about the FBT of 2 kg, this second block during this case 1 scenario, then what will happen? Upward force will be Fs2 and below will be its weight. So this means that what will happen? There will be an acceleration of this block in which direction? Upward direction. So one, in this case scenario, one block goes up. This 10 kg goes up, and when you cut the second spring, and 5 kg falls down. Is that clear or not? So this implies that acceleration of second block, or acceleration of 10 kg block, you can say, will be pulling force, means this one along the acceleration minus opposing force, which is its weight, divided by mass of the body, which is 10 kg. So how much is this? Simple. Fs2 over here, earlier it was what? Spring force first will become 0 or not? When you cut the spring force 1 will become 0. Okay, it will disappear. But what will not change is Fs2. Is that clear? So 150 minus 100 divided by 10. So acceleration of this 10 kg is 50 by 10, which is 5 meter per second square, and that is in which direction? Upward direction. Is that clear or not? Case 2 of this, when spring 1 is cutted. What happens when the spring 1 is cutted? What happens when the spring 1 is cutted? Any answer? Any answer? When we cut the spring 1, whereas any answer? No answer. G, correct? Now this is what you are saying. Acha. Look over it. See. When the spring 1 is cutted, what will happen? For this 10 kg, means at that instant of time, when the spring 1 is cutted, Fs2 will become 0. What will not become 0? is Fs1 and Fs1 is not equal to 0. I have already told you springs are lazy. Springs are not going to change its state if they are cutted instantly. Are you able to get me or not? Their values will not change. Means what will happen over here is this for 10 kg, Fs2 will become 0 and Fs1 will not become 0. So look over here, what that will do. This is 5 kg, this is Fs1, this is also spring force 1, this is the weight of the body. And Fs2 has become 0. So Fs1, this is Fs1, this is 10g, this is 5g. So look over here. For 5 kg, still it is in equilibrium. If Fs1 is not changing, so Fs1 will balance this 5 kg weight or not. Until and unless this spring gets fully compressed. Are you able to get me or not? What is the meaning of this is, means when I cutted the first spring, this block on top of it starts to fall on this mass M2 until and unless, see how this will fall, this one will remain at rest until and unless this mass comes over here, compresses the spring, again it can compress the spring until and unless too much large, means maximum compression does not happen, these both blocks will not move. Is that clear or not? Are you able to get me or not? Means their movement is only there when the maximum compression happens. Till that this 5 kg is at what? Rest. Clear? So what is the net acceleration then? Therefore, acceleration of 10 kg, pulling force Fs1 plus 10g divided by mass है. घर पे बहुत गंदा आवाज आ रहा है, माइक ऑन करके मत रखो. So Fs1 is how much? If you look over here, Fs1 is 1, sorry, Fs1 is 5g. 5g means 50 plus 100 divided by 10, which is 150 by 10. This is 15 meter per second. Means this 10 kg falls with a large acceleration when the first spring is cut. Are you will get me or not? This one will fall down with some acceleration. Other one will be at rest. Is that clear or not? Yes. So this is the meaning of cutting off the springs. Are you able to get me? Now, next part. The spring nature. Vertical case. Or let us just write the spring nature. Now, let's suppose I took the spring, attached with a block of mass M. Okay. Or let us understand this in vertical. Vertical only you can understand this properly. See, I have the spring. I attach with a block of mass M. And this is present over here. 1 minute. Let me bring this whole setup at the center little bit here. Yes. So now this is present over here and spring constant is K. Weight of the body is M. Mass of the body, sorry, not weight. Mass of the body is M. Now at T is equal to 0, it is released from this point. Released. This we call it as, in the spring, as we know that this is called as natural length point. What it is called as? Natural length, correct? Now as this is released from here, what it will do? It will start expanding this spring and it will go. Question arises that as you can see this motion, this whole spring motion categorizes of three parts. See, this mass M, as it has a weight mg, and this is its spring force which is acting. Now what is happening in this region, that as you know that spring force is what is the formula of spring force? K into x, correct? Means as the x will increase, the spring force also increases. So till that time, this spring force means what is happening? As this mass is going down, spring force is trying to increase and trying to balance it. So what will happen? You can see that this mass will come down over here. Okay. Means let's suppose this mass comes down over here. Is that clear? Word or not? And this spring got stretched. Now, means I'm considering a point which we also call it as equilibrium point. This point I call it as equilibrium. What happens at equilibrium? We know that whatever is my pulling force over here is how much? Mg. And our spring force is there, correct? So at equilibrium, we know that, sir, we have learned that whatever is the spring force, upward force, that will be equal to which force? Downward. So Fs becomes equal to what? Mg. Here Fs is 0 at this moment of time. Here Fs is equal to mg, means spring force is trying to increase. It means in this region you can see that spring force is less than mg or not. Now what does this mean? Let me have a quick understanding. Let's suppose there is a block which is placed on a road, okay, and there are three time frames I'm drawn, okay. This block is present at three different times. T is equal to 0 second, T is equal to 1 second, and T is equal to 2 seconds. Over here, this for this mass, I don't consider any mass. Okay, let's over some blockade, blockade, blockade. In this region, I applied an acceleration of 5 meter per second square, and in this region, I applied an acceleration of 2 meter per second square. Over here, my velocity was 5 meter per second. Then find the velocity at this t is equal to 1 second and find the velocity at t is equal to 2 seconds. Tell me fast. Look into that and tell me. I'll just bring my water. Okay, so I can apply, means you applied the formula v is equal to u plus at. Here it is 5, acceleration is 5 and time is 1. So I found out that velocity over here becomes 10 meter per second. And again, if I apply 10 plus 2, then it is 12 meter per second. Means what you saw that from if I look into the particular diagram, then from this time to this time and from this time to this time, in that what is happening, acceleration value, the value of acceleration is decreasing. From here to here I found out that acceleration is decreasing. But does that means that the velocity decreases? No. This means that rate of change of increase in velocity decreases. Means initially the body was increasing its speed faster, but a little bit it is slowly increasing. Means decrease in acceleration does not mean that the velocity will go to zero. Decrease in acceleration means velocity will still be increasing. Are you able to get me or not? So I can say that from here to here, velocity still increases. So question arises, when does the word velocity decreases? Simple idea. Velocity decreases only when acceleration is negative, not positive. Velocity decreases when acceleration is negative. Is that clear? This is the meaning of change in velocity or something like that. Means even if the acceleration is having 0.00001 value, a little bit also positive, it will increase the velocity. It will not decrease the velocity. Are you able to get me or not? So over here, as you can say that in this region, spring force is less and mg is more, means downward force is more, spring force is less. So in this region, what is going to happen? Our velocity is going to increase. From here to here, velocity increases. In reality, if we can say over here at this point, I have maximum velocity. Which kind of velocity? Maximum velocity. Is that clear? Now, furthermore, means as we can say that the body is at maximum velocity at the equilibrium position itself. So I can find my expansion over here or not. I'll come to that little bit later on. I'll first make you understand and then I'll do the calculation. So first, my velocity become maximum. Now body will not stop. This means that at this point body is not going to stop. Body will stop at zero velocity. So what will happen? It will furthermore expand it. It will furthermore expand the block. And over here it will come. Now as it comes over here, now see, now in this region what has happened, our spring force, now as it will go down in this region, spring force will start dominating. Why? Because you know that as the length increases, spring force increases. So here what is happening, this is mg and this is spring force. So in this region, the spring force is greater than mg. Is that clear or not? And this is what we call it as extreme point. Okay, the point where velocity becomes how much? Zero. and this is called as maximum expansion length. This is called as only as the word x max, and this is called as x naught, means expansion till equilibrium. So in a spring scenario, in a vertical spring scenario, there are two kinds of systems. Okay, there are two kinds of expansion. One, when you reach equilibrium, which is at x naught. Another, when you reach at extreme point, which we call it as x max. Is that clear or not? Are you able to get me on? So look over here. If you consider till equilibrium point, expansion, first case, expansion of a spring at equilibrium, expansion of a spring at equilibrium is given as, simple idea, I can write the equation, spring force is equal to mg, which we write it as kx naught is equal to mg, and this x naught is equal to how much? Mg by k. Is that clear? This x naught is equal to how much? Mg by k, means still here equilibrium it is mg by k. The question arises, what is the value of x max? Think, what is the value of x max? So let's suppose if I want to write the acceleration equation. So if I want to write the equation of acceleration, what will be equation of acceleration? Simple idea is that, sir, acceleration will be mg minus fs now. Initially, this one is dominating. Divided by, is that clear or not? Now, spring force is what? K into x, correct? Spring force is what? K into x. So, look over here. If I write so, acceleration is equal to mg minus spring force divided by m. So, this can be written as A is equal to g minus k by m into x, because this is the equation of, so this you can see that this acceleration is dependent on position. Right or not? Dependent on what? Position over here. Are you able to get me or not? Now, as it is dependent on position, I can write the acceleration in terms of velocity, which we write it as v dv by dx, which is g minus k by m into x. Bring this dx over here. V dv is equal to g into dx minus k by m into dx. Integrated. Now, what happens if I look into x max? Over here velocity is 0, over here velocity is also 0. So this term is fully how much? Initially it is 0, finally it is 0. Initially expansion was 0 and finally expansion is x max. Initially expansion is 0 and finally expansion is how much? X max. So this is what? G into x max is equal to k by m x max whole square divided by how much? 2. So x max cancel. This implies that value of x max is how much? Twice k, sorry, twice mg by k. Now this means that this x max is nothing but 2 times of my equilibrium expansion or not. Look over here. What we found out? Equilibrium is how much? Mg by Okay, acceleration equation is this. So this means that expansion of a spring till maximum stressing is nothing but, how much is that? X max is equal to twice of x naught, or this implies x max is equal to twice mg by k. Is that clear or not? This is the whole derivation of this spring idea. Means, keep that in mind when we are considering a spring. There are 3 points in the spring: natural length, equilibrium length, extreme point. From if I consider from 0 to equilibrium, velocity of the body is going to increase and velocity becomes maximum at equilibrium point. Got it or not? When I consider equilibrium to my extreme point, spring force is dominating, so velocity will decrease, and finally at extreme point velocity will become how much? 0. So look over here, there is an expansion from natural length till equilibrium, which we call it as x naught, and that is equal to how much? Mg by k. Are you able to get me or not? And there is an expansion from the natural length till the extreme point, which we call it as x max. So I got to know how to find even x max. Look over here, we have done the, you have used acceleration equation here, which is dependent on position, and then based on that, if I do the integration from the natural length, this point is representing, initial point is our natural length, and this point is my extreme point. Now you can use this acceleration equation for any kind of point. Let's say if I want to find the like let's say some x value is given and you want to find the velocity over there or expansion over there, so you can use this equation using integral method. You can also do that. Is that clear? Saying something else? Is this perfectly clear? Or so what we learned that means, if you think of the spring, if you look into the spring, like suppose this is my horizontal case of spring, I took the spring attached with the block, this is my natural length. First, this body, if I'm expanding, will reach to an equilibrium point, which we also call it as mean point. Now as it reaches the mean point, its velocity will be maximum, then it will go to some, let's suppose this we call it as extreme point, and it will oscillate over here if there is an external force. If we use the method of compression, again it will go to first equilibrium point, then it will go to some maximum compression, and it will oscillate over it. So idea is that oscillation, if you look into the oscillation, whatever is this length and this, then whatever is this length, they are what? Same. Means right of the equilibrium or left of the equilibrium, if there is no resistive force, they are going to be what? Same. And this is why these are called as extreme points, and the gap between two extreme means and the gap between the equilibrium point and extreme point is called as what? Amplitude of oscillation. This is the total meaning of spring forces. Are you able to get me or not? Clear? This means from here to here, it is called as amplitude, and the oscillation will happen till natural length only. Means in this only the oscillation will be bounded. Are you able to get? So this was all about your spring forces. So based on this, we can define our spring potential energy. Uh-huh. What? Potential energy. Uh-huh. Okay. I'll come on that. Spring potential energy. Or work done by spring forces. Simple idea. Let's suppose I took one spring, I attached with one of the block, and this mass is at its natural length state. Okay. I applied an external force. Right. So over here, if it is at, if this mass is at natural length, then what will be our spring force? The spring force will be zero at that time. Is that clear or not? Now, next point. Next point, if I consider, a little bit more expansion, okay, अबे वो दो कौड़ी के इंसान यूट्यूब लाइव पे जो कमेंट कर रहा है, हाँ, तेरे जैसे लोगों को बाप भी सिखा देना, बाप की औकात नहीं है। Now look over here. Let's suppose if there is this mass and I expand till x1. Is that clear or not? So look over here. What is going to happen? Let's suppose I first expand it till x1 with some help of an external force, and then again this is my spring force. It will develop some spring force over here. Wait or not? Oh, 1 minute. Okay. So if I consider this, let's suppose if I expand this block till length how much? X2. Right or not? And this is mass M. So I expanded till x1 and then I expanded till x2. Now question arises that what is this work done by spring? It's like first, so look over here, means x1 and x2 are displacement of the block from their natural length point. Okay, from their which kind of point? Natural length. Are you able to get me or not? If I consider 2 points, 2 displacement is okay. Now, if I consider this particular displacement equation, so question arises that what is the work done by our spring? So now we know that work done by any kind of force is F dot dx if it is path dependent. As we know that spring force, if we write this spring force, it is written as k into x, means it is dependent on position, means little bit will also change of position. What is going to change? Spring force is going to change. Are you able to get me or not? So basically, if I apply this formula, work done is equal to integral kx into dx. And then look over here, from where to where I'm going in the x, I'm going from some x1 to some x2. If you look into the second point, this is dot product over here, f dot dx, which means that if I consider the spring force and if I consider the displacement, I have to consider the angle between. How much is the angle between them? Displacement is towards right, spring force is towards left. So this means that angle between them is how much degree? 180 degree. So I'll have to use negative sign over here. If I integrate it, x integration is how much? X dx integration is x square upon 2. So what I'm going to get? Minus of 1 by 2 k x2 x square minus what? x1 x square. Is that clear or not clear? Minus of 1 by 2 k x2 x square minus x1 square, and this is called as what? Work done by spring force. Now, why I talked about this, why I talked specifically about work done by spring forces, what does this formula represents? As you can see that x1 is the expansion. Let's suppose I call this as my initial point, and this I call it as the final point. So you can see that the expansion was from initial point to final point, and at every moment my spring force was changing. What I found out in the work done, that work done over here by the spring force is only dependent on final point and only dependent on initial. It does not matter how you have taken from x1 to x2. Like if I am taking this spring from x1 to x2, like either this way or this way or this way, if this is x1 and this is x2, it does not matter if I have taken like this way or this way or this way. I just need the work done, means what I'll find out that the work done is simply equal to half k x2 square minus x1 square, means it is not dependent on how you have taken the spring in these positions. Are you able to get me on? It is only dependent on initial point and only dependent on which point? Final point. Are you able to get me or not? Is that clear or not clear? So this is the work done by spring force equation. Are you able to get me? Now, so first point is clear, that work done by spring force is not dependent on the way you have stretched your string, second point, this work done is independent of path, and third point, this work done is dependent on only initial and final. Is this clear or not clear? So we got our everything of spring today in a simple manner. We did so many things on spring. A major part was spring forces and bringing the spring under the idea that what will happen when we cut the springs and what will happen to its. There are two kinds of expansion: equilibrium expansion and a maximum expansion. And ultimately we try to write the formula of spring forces and what is the property of a spring force work done. That's what we have written. Is that clear or not? So we will stop it till here. Tomorrow we are going to plan